Good morning, everyone. Welcome to the third day of our virtual GSC conference. It's the last day, but not the least with the presentation that we offer. So feel free to join as much as you can today. But obviously, we are here for what's new in MQ, presented by Jamie. So without further ado, Jamie, over to you if you want to introduce yourself and crack on with your presentation, please. Sorry, just to mention the questions, maybe. Let's put the questions in the chat so we can read them to Jamie and he answer on the go or at the end, if that's okay. And yeah, that's it. Thank you very much and crack on, Jamie.
Okay, yeah, thanks very much. So welcome everyone. Good morning for those in real time and welcome to those watching on replay. So this session is going to be talking about what's new in IBM MQ and what we've been doing over the last couple of years or so as we've been working through the various updates that we've been introducing over that time. So hopefully most of you are aware already now because we've been doing this for several years. But in MQ, we have a kind of like a two-model consumption for the product. We have what we call long-term support releases, which are ones where we provide new function and then we then stabilize that and then we just provide corrective maintenance on that release for a period of 5 years for normal support and an additional 3 years for those that pay for extended support. And that gives people maximum stability for those environments where they really don't want them to be changing too often or they're particularly critical to the environments they're running in. We also have what we call a continuous delivery model, whereby we release regular functional enhancements over time, typically every like 3 to 4 months or so. And that model then provides customers with the options to take new features on a faster cadence. We see different ways that customers use these two approaches. The continuous delivery releases can be used to really exploit new function as soon as it's available. It can be used to expose a new function into dev and test environments so that you're ready to really kind of like run with those features once they hit a long-term support release. And because you can mix and match the two in the different environments because they're fully supported and compatible with each other, you can actually use continuous delivery deployments in some places and long-term support ones in others based on the needs that you have. So last year, we actually released our latest long-term support release, which is 9.3. So in this session, we're going to talk about some of the enhancements that have been rolled up into that. And then as we then have moved on to continuing with our continuous delivery model, we're then going to talk about what enhancements we've delivered in 9.3.1 that came out after that. So this slide just gives you a summary of some of the main enhancements that we've rolled up into the 9.3 release over the last couple of years. I'm not going to go through all of them, but you can obviously read them there to see what options are there, as well as going and looking at our fuller documentation. But it's worth just looking at some of the different kind of like slants on this information. So firstly, for those that are on the continuous delivery framework, the 9.3 release is also a CD release, as well as being stabilized for longer stability. So therefore, we've got a bunch of other enhancements that are brand new to 9.3 over and above 9.2.5. And we're going to talk about some of those in this session. We also have been making quite a number of enhancements to focus on applications, particularly to support new environments where applications might want to run to perform messaging, and also to support new capabilities and features that those environments demand. So this could be supporting newer versions of Java, the Jakarta messaging standard, supporting new models of consumption, environments in such as cloud and containers and scaling using things like Kida. And also updating and supporting things for REST messaging APIs for those that want to deploy lightweight applications in a wide range of environments. We've also been focusing on security enhancements, as we always have done. So doing things like introducing support for TLS 1.3 across the product, supporting disk encryption on the MQ appliance for those that want to deploy into environments with sensitive data or regulated environments, updating to support PKCS 12 key repositories for more kind of standard tooling use, which we'll cover in a bit more as well. So we continue to address different updates in the security space, and we'll always continue to do that moving forward as well. So availability is also a key theme that we are continuing to enhance. So there's a number of enhancements in the 9.3 release over and above the 9.2 release that came before that, to provide new options for increased availability, things such as new DR support for the appliance, native HA support, which we'll cover in a moment. And also things like streaming queues, which is another important enhancement that we're going to be discussing. We know that many customers are needing to become more efficient with managing their own infrastructure. So we also are continuing to invest in lots of enhancements to support operational needs. So you can see there's quite a number of enhancements here to allow you to to improve operations in your environments, achieve things that you couldn't achieve before, but also be more efficient and remove constraints. So, so again, we'll talk about some of those as we go throughout the session. So as you can see, we've covered quite a lot of enhancements and in different main areas, be it applications, availability, security, and operations. But we've also covered enhancements that are targeted at all the different environments that MQ focuses on. So this is ZOS from the mainframe perspective. We've got some specific enhancements there, some for the appliance, some for the other software environments that we support, cloud platforms, and also just enhance our container support. So we've tried to cover a broad range of features and enhancements as we move forward, and that's likely to continue into the future. So before I start going into some of the features, I also want to just make sure that people are aware of a change that we made at the start of this year, so last month, around how we deliver maintenance for MQ on the distributed platforms. So that's like the Windows, Unix, Linux environments. So we've historically provided fix packs, which are a roll-up of APAR fixes for maintenance, and we've done those over a period of time, spread out maybe several months apart. We are going to continue with that model, so you'll still have fix packs, but we're also now going to provide what we're calling cumulative security updates. So previously, these might have been delivered as targeted interim fixes, which had a different kind of consumption model. These security updates are now going to be provided in the same kind of installation model of fix packs before. So you'll get a new package update with an updated fix pack number, i.e. the F number at the end, and that will be the same whether it's a fix pack or a CSU, as we're calling the cumulative security updates. The way that you can tell the difference between them is that the fix packs moving forward will have the final digit of the VRMF being a multiple of 5. So you'll have fix pack 5, fix pack 10, fix pack 15, and all of the other interim numbers will represent cumulative security updates as we need to release them. So if we're on fix pack 5 and then we want to release a security update, that will then become essentially what would have been previously fix pack 6, but it's now just a security update, which is just a smaller revision on top of the fix pack with just a few security enhancements there. The next one would then be number 7, number 8. If we then wanted to release a fix pack, we would skip 9 and move straight to 10, so that it's always a multiple of 5, so that you know what you're installing. We're going to provide those CSUs no more than once a month, but obviously only as necessary, and we'll provide them based on all the supported LTS releases plus the latest CD release. So there's various FAQs around this in the article that I've provided the link for in the bottom right, so you can go and read that to understand a bit more about how this is going to work. Because this model is also how we've delivered updates for the JMS client and MFT for files transfer and the web console on ZOS, those will still also represent the same VRMF numbers, but how the rest of the maintenance is delivered on ZOS using APARs and PTFs and so forth will remain unchanged, because that provides the flexibility that we need to be able to do this anyway. Okay, so now if we move on to looking at some of the innovations that we've been making in the 9.3 long-term support release. So the first theme we're going to look at is how you can get insight into your data. And particularly, we're going to look at a new enhancement that we've added we're calling streaming queues. So for many years, we've worked with customers and been asked to provide guidance on how people can gain insight into the messages that are flowing through their system. You don't want to be disrupting the messages as they're flowing through from application to application, but there's often valuable reasons why you might want to understand what that data is and what's going through. Particularly now, as we're starting to look more at event streaming, there's lots of use cases that people are coming up with around how you might want to maybe send copies of data to other places to do parallel processing. And so we've added this new feature called streaming queues, where you can configure a queue to actually send a duplicate of every message it receives to another queue that you can then process as you need to. Now, there are a number of use cases that you might want to consider for this. The first thing is that second copy of the data might then be used to flow into event streaming platforms such as Kafka and things like that you can then farm out to various places. But you might also just want to have a copy of the data that's flowing through your environment so that you can replay it later, or you can replicate it into our test environment so that you know that you're actually working with real representative data. Should your kind of like environment be allowed to do that in terms of the data that you're having? Not everyone's going to be able to kind of like take copies of real production data, but for those that can, that's a valid use case. And also for audit and replay. So you've got an identical copy of the messages, so you can use that to store evidence of what's flowed through, or even just to kind of replay those messages later if you need to because of an application outage or something like that. Previously, some customers might have configured MQ's publish subscribe capability to kind of achieve a kind of like a similar thing, but with publish subscribe, the messages weren't completely identical because they'd have different message IDs and correlation IDs and things like that. With this particular enhancement, the messages are exactly the same. So you're getting a complete copy of what you've previously had. So I mentioned before that you can use this to kind of like take copies of data to replay and test environments. So that's one of the examples that customers have asked about. And so, yes, you can now obviously take copies of those and then use those to replay to check for performance or functional capabilities if you're making changes that you want to deploy out in your environment. I mentioned event streaming. So yes, you can you can't use MQ to do everything that an event streaming platform like Kafka would do, but it has lots of kind of common qualities. And so if we just look at what you can do with an MQ itself, you can obviously have the messages being flowed to a second queue as I've described. And then you can then use an MQ feature called cap expiry, where you can ask MQ to expire messages after a period of time, which allows you to keep a rolling window of history of messages that have flowed through the queues without actually needing to consume messages manually to avoid the queues filling up. So this allows you to keep a recent history of those messages, which you can then dump and replay if you need to in the future. So that sort of allows you to do a kind of a fairly efficient way of achieving messages in your environment. But you can also then stream them off to event streaming platforms to get a wider range of capabilities if you need to. Another use case that we've had people ask about is for disaster recovery support. Now MQ has built-in features to provide HA and DR for those environments that need high availability, but you can use this to do a form of DR if it's appropriate for you. So you could again take those messages to be sent off to a remote queue manager in a remote location. It will allow you to have a copy of those messages that have flowed through, but it won't replicate the consumption of the messages, just the delivery of them. So depending on your environment, on your use case, you may find that's useful. You may find that you need to use one of the other features that MQ provides. Okay, so if we now look at some of the application enhancements, as you saw from earlier on, we've delivered quite a few enhancements to address application needs in 9.3. So we keep looking at expanding the particular platforms and APIs that are needed for applications. Today, we've been enhancing our REST messaging API. So in 9.3, you've now got support for message properties as well as browsing and sending and receiving messages as you've had before. We've been enhancing our AMQP support to include Apache Cupid JMS clients to allow you to use a wider range of messaging clients in your environments, particularly maybe for compatibility with other tooling and things that you want to use. And we've also been building out support for something called Async API, which is a evolving framework for allowing you to define endpoints that applications want to connect to in the same way as other APIs, but which actually drive asynchronous activities such as the sending and receiving of messages. So if we now look a bit closer at availability and scalability enhancements that we've been making, with a particular focus on message availability. So we can see that there are two types of quality service that we need to be mindful of. The first one is data resiliency, which is around making sure that your messages aren't going to get lost, they're protected from system failures. And then there's also the quality of making sure that if something does happen that causes the service to go down, that actually you can get the service back up and running quickly so that you can gain access to your messages and continue processing. So these are two particular qualities that often go side by side, and MQ has been had a number of features over time to provide resiliency that address one or both of these to different extents. So initially, MQ supported high availability configurations using what we call external solutions. And this is where you would use some external software coordination to provide resiliency by restarting the queue manager if something went wrong. That could be either restarting it on the same system or restarting it on another system using shared network storage to provide availability to the data. And then we added something called multi-instance queue managers, which provided a similar capability, but built into the MQ product. So you could have an active and a passive instance of the queue manager, and then using kind of file system locks to start on one node or the other based on your needs that you had. We then evolved to provide more integrated solutions. So on the ZOS platform, we've got queue sharing groups, which is probably the most functional resiliency option that we have for the MQ across all the platforms, exploiting the coupling facility and the Sysplex environment on the Z platform. On other platforms, we have the MQ appliance, which is a hardware device which runs MQ and only MQ. You can use that model to pair appliances together to have data being replicated between them so that you can have automatic failover with queue managers and resiliency across larger distances too. And then we added something called replicated data queue managers, which provides a similar capability to the appliance, but on just standard Linux platforms, on Red Hat Linux. But this time we built in a kind of a quorum of 3 nodes to make sure that the queue manager only ever runs in one place because of the flexibility that the Linux environments have based on where you're deploying it in kind of virtual environments and so forth. But as we've been moving forward, with each of these solutions has targeted specific environments, but actually they've all got pros and cons, as generally everything does in life. So we've also now been building a new capability, which we're calling Native HA, which is very kind of similar to the qualities that you would have with replicated data queue managers, but which is built into the MQ product, so is more targeted to environments such as container frameworks and doesn't have some external dependencies that the other solution demands. So if we look at Native HA, Native HA has essentially 3 nodes, 1 active node and 2 replicas. Those 3 nodes form a quorum, so that ensures that we only ever have the queue manager running in one place. And in this environment, the data is being constantly replicated from one queue manager instance to the other replicas. And because we're building this internally in MQ, it's the queue manager recovery log that's being replicated between the nodes. So every time any MQ writes anything to its log, that data is being kind of synchronously replicated to the other replicas. So if the active instance fails for some reason, then one of the other replicas can take over and host that service. Each of these nodes just has its own local storage that's private to it. So you haven't got to worry about providing shared storage in kind of container environments that where OpenShift runs, where this feature is available at the moment. And because these replicas and that are able to exploit the facilities that are available in this environment, they are able to heartbeat each other and they have automatic failover as soon as something happens, be it because of an error or because of rolling maintenance that you might want to do. You might want to be kind of pushing out an update throughout your container pods, and so you can take one container image down at a time, and then the queue manager will fail over to one of the remaining instances. So there's no external dependencies here, and this solution uses is based on a framework called Raft, which you can search online. It's a well-documented way of achieving a quorum framework with rapid failover. So it's particularly designed around sequential writing to logs, so it works very well for MQ, which is based on this model. So if we go back to look at some of those qualities I mentioned around availability and resiliency. So first off, we can start off with having a single queue manager that's built on one of these resiliency options, such as native HA, at which point we'll have an active instance and some passive standbys. So this provides data replication because we've got the data being stored in multiple places, and we've got consistent fast recovery due to how the HA solution there works. But because we've only got one active queue manager at any one time, because the queue manager is only going to be active on one of those nodes, we don't have any workload balancing or active environments where applications can connect to multiple places. So to provide active and workload balancing capabilities, we need to add multiple queue managers. So by adding multiple queue managers, this provides additional endpoints for applications to connect to, and then those applications can then be balanced across those queue managers to provide maximum kind of like throughput features. We got a question in the chat. Is native HA also available or recommended for ZOS systems? So native HA is currently only available for Linux environments in Cloud Pak for integration on OpenShift. So it's not available on ZOS itself. As I mentioned, ZOS has queue sharing groups, which provide all of the kind of qualities of service that you would need for a highly resilient solution. So queue sharing groups are really the premier option for the ZOS platform. Okay, so so if we kind of move on and look at horizontal scaling, so if we just put aside the HA options for how queue managers themselves might be made individually resilient and focus on just having a number of different queue managers providing a kind of like an active environment for applications to connect to, we can have multiple active queue managers, and those messages can be workload balanced across the queue managers. And then the applications then need to be able to connect to all of those queue managers to be able to process all of the workload. But some applications can connect to some queue managers. You haven't got to have every application connecting to every queue manager in the group. So on ZOS, this model can be achieved by using ZOS queue sharing groups, which provides obviously the features of having multiple queue managers that then expose collectively a set of queues that applications can access. On distributed platforms, the model that we're using to achieve this pattern is something that we're calling a uniform cluster, which is an MQ cluster, which is something that MQ has supported for a number of years now. But a uniform cluster is a specific kind of like flavor of using MQ clustering, whereby each queue manager in the group provides access to the same queues and supports exactly the same applications, rather than different queue managers performing different roles within the cluster. So when we know that you want to use a set of queue managers to provide equivalent capabilities for applications to connect to, then MQ can start to provide some additional features to allow you to exploit that pattern. So in a uniform cluster, the queue managers are able to share information with each other around the applications that are connecting to them, so that we can then use techniques to ensure that the applications are being balanced across the queue manager instances in an even way. So this then allows us to rebalance applications as we add or remove queue managers based on your scaling needs. So if we look at this step by step, we can have a number of applications that are connecting in, and they want to connect in to the cluster as a whole rather than specifically targeting one of the queue managers. So they will then attempt to connect in using facilities that we might provide, such as a CCDT or other kind of like network endpoint, to just connect into somewhere in the cluster. They then initially will get routed to one of the queue managers in the group, but the distribution won't necessarily be optimal for kind of like even processing and kind of distributed workloads. So the queue managers themselves will now be able to detect this and will then target specific application instances and then direct them to reconnect to specific queue managers in the cluster to kind of even out the connections across the queue managers. And this then allows us to, and this was constantly happening, so if we add and remove queue managers, then the applications are being reshuffled around to ensure that each queue manager's got at least one application instance connected to it, assuming there are enough applications that are there, and also all the applications are connecting to somewhere that they need to. So in the 9.3 release, we've been enhancing the support in this area. So we've added support for message-driven beans for Java applications running in JEE environments. And we've also been adding some more enhancements to support application patterns, such as applications that are doing request reply. You don't want the application to be moved to connect to a different queue manager whilst it's waiting to reply for a request it's sent. So by telling MQ that that's the pattern the application has, then we can actually wait for a reply to be received before asking an application to move elsewhere. Similarly, for those applications that are performing multiple messaging operations within transactions, you don't want to be forcing the applications to move to a different queue manager in the middle of a transaction. You want to wait until it's completed that unit of work before asking it to move. Otherwise, the transaction gets rolled back. So, so again, we've added some capabilities here to be a bit more intelligent around when we might ask applications to connect to a different queue manager in the group. Okay, so we've had a lot of customers talk to us around cloud native, and is MQ cloud native, and how can it be, because it's been around for so many years. But actually, if we look at what actually is defined by cloud native, it typically means a number of qualities that applications have to support modern cloud environments. And these are primarily defined in kind of like a number of distinct categories. So the first one is that cloud native applications can be containerized and run in container environments. MQ's been supported in a container for many years now, so MQ can definitely kind of like tick that box in the set. MQ has been designed from the outset to be loosely coupled and support kind of flexible deployments. So MQ definitely addresses that requirement. We've been talking around some of the scalability features for high availability, resiliency. We've just been talking about native HA, around how you can dynamically add and remove queue managers and have applications spread across the uniform cluster or the queue sharing groups. So again, MQ can tick that box. And then typically the cloud native applications use replication to provide resiliency. And again, MQ has options that provide that too, including native HA. So actually, if you have conversations around the fact that people might think that MQ isn't relevant in the cloud native environment, actually, there's very good arguments for saying that actually that's not true. MQ is perfectly suited to this and actually supports and has all the qualities that you would associate with applications that are designed for this environment. So if we now look at some security enhancements that we've been making, so MQ has on the ZOS platform, MQ uses RACF for so forth to provide support for certificates and so forth. On the other platforms, we've used a kind of proprietary format for the key repositories where the certificates are stored. In the 9.3 LTS release, we've added support for the PKCS 12 standard, and this opens up possibilities for you to use a wider range of industry tools to manipulate certificates. So you can now use this particular certificate format for your queue managers and your applications. So you can use that for standard kind of like MQI applications and unmanaged .NET applications on Windows. For other environments such as managed.NET, you can use the Windows Certificate Store, and for Java and JMS applications, then the JRE has supported this format for a while too. So actually, you can now exploit PKCS certificate in a wide range of environments that you need to use that if you want to use this to integrate with other tooling. Similarly, the CMS format that we've used and supported in the past, which has demanded you use a as the option of using a stash file to provide access to the key store rather than using a password and so forth. But the PKCS 12 format doesn't use a stash file, so we've added the option to allow you to define to the queue manager or your clients what password you need to access the key repository in order to gain access to the certificates. So for the queue manager, that's going to be protected when it's stored. For the clients where you might want to define them in configuration files and so forth, there's a tool that we provide that allows you to encrypt the password so you're not storing it in visible plain text in the config file. Both these enhancements kind of go side by side to allow you to kind of exploit this particular new, this particular format for queue repositories that we've seen customers have a need to want to do. So another enhancement we've done has kind of been primarily targeted around running MQ in containers, and this is around supporting a new model for users and identities. So MQ has required a local username to be defined on the machine for doing local OS authorization checks. And that's where MQ uses the local user's group membership to then define what groups that user belongs to, which you can then define authorities in MQ against. In container environments, you don't necessarily want to be defining local users because of how those containers are started and deployed. And although MQ also supports things like LDAP, you might not necessarily want to be running in an environment using that to get in users from elsewhere. So we've now got another option for called user external, where essentially you don't need to define the users locally. So it's only available on Unix systems. You still need to have a layer of authentication to ensure that the user is trusted, but then you can then define authorities against the user rather than requiring them to belong to groups that have to be defined on the machine. So with our standard model, you have users that must exist locally, either in your operating system or potentially in the LDAP server, and then we can then query that group membership, and then you define the authorities against the group. If you define user external as the mode you want to, then we don't attempt to, say, query group membership, and you just define the authorities against the individual users, and that provides some additional flexibility in those environments. As we move forward from each LTS release to another, we do occasionally deprecate features that we don't see as being either able to be supported or a demand for in the future. or because we've been provided new capabilities that are a better solution for those capabilities. One of the things that we have deprecated is support for 32-bit applications, not to be confused with 31-bit applications on ZOS. So we are increasingly seeing that the environments such as Windows, Linux, and Unix, and so forth, are the 32-bit support for all the different components that you might need in your environment is gradually becoming replaced with 64-bit as a kind of an ubiquitous standard. So although 32-bit support is still present in 9.3, and we're just kind of putting you on warning that future releases might kind of need to remove that because we can't provide the 32-bit layers that you need for all of the features that MQ supports. We've also deprecated a number of ciphers, both for AMS, which is our advanced message security feature to kind of digitally sign and encrypt individual messages, but also for our SSL and TLS support for kind of network communication. These ciphers are now generally considered to be weak, so we're deprecating them and we've obviously got stronger ciphers that you can use instead. In the future, those weaker ciphers might just be removed completely, so we're just kind of deprecating them now to give you advance warning. And then there are a few other little options that we've deprecated for those customers using our managed file transfer enhancement, where you can use MQ to actually transfer file data as well as just application data in messages. Okay, so there's kind of like a brief overview of some of the major features that we've added in 9.3 release. As you saw from the start, there are actually quite a lot of features there, and we haven't got time to go through them all in this session. So if you're interested in any of these features, then yeah, you can look in our documentation and see all of the different details around what they all are. We just wanted to give you a flavour for some of the main things there. So I now just want to move on and talk around some additional features that we've added in our 9.3.1 continuous delivery release. So this is the first iteration of providing some enhancements over and above the 9.3 long-term support release we've just been talking about. So with continuous delivery releases, as I mentioned at the start, these are made available approximately every 3 to 4 months. And each one builds on the other one, and for customers running in this environment, you're generally kind of expected to keep moving with the continuous delivery train, taking on the new updates as you go forward. Each release, CD release, is still supported for 12 months, so it's not like you've got to move up as soon as we release a new one, but you've the intent is that these releases aren't themselves supported in terms of providing fixes for the whole length of time that the longer support releases are. So 9.3.1 came out at the end of last year, and so there's a few new features in this that we want to talk about, including some specific enhancements for the ZOS platform. So the first thing that we've done on ZOS is to actually enhance the channel initiator address space, which is what provides the network connectivity for applications and queue managers where channels run, so that it actually has moves a lot of its storage above the bar to the so that it can take advantage of 64-bit storage instead of being constrained by the limits of 31-bit. This is something that's been on our backlog for quite a while, and by moving the channel initiator to be able to exploit above the bar storage, we can now actually support significantly more channels coming in directly to the ZOS platform. So you haven't necessarily got to have additional queue managers sitting in front of your ZOS platform, providing a kind of like a connection concentration feature to reduce the number of channels that are coming up to ZOS. So with this, if we look at the example that we're seeing here, we've got 104 clients all sending 10 megabyte messages. So if you kind of like do the maths there, you can work out the footprint that the channel initiator would need to allocate memory to kind of support those messages. And we can see that in 9.3 LTS and prior to that, before this feature came in, all of that storage, all the buffers to store those messages would be below the bar, and therefore we would need about 10 megabytes of storage below the bar to support that. which provides a cap on how many channels you can support coming in, because you've only got so much storage free below that bar line. With 9.3.1 and beyond, where we've got support for using above the bar storage, the majority of that those buffers are now defined above the bar, so we're using much smaller amount of storage in the 31-bit space, which then means that actually we can now support much larger numbers of channels coming in. So in this particular example, we could actually get to the maximum number of clients that MQ allows, which is just shy of 10,000 connections coming in, without exhausting the space that we might have in the 31-bit area. So we've updated our samples to kind of exploit this by default. Obviously, if you've got existing queue managers, then you'll just need to update your mem limit of your channel initiator address space to make sure that MQ has access to the storage above the bar. Okay, so another thing we've been doing in recent time is looking at our SMF statistics and adding some additional support there to allow you to gain more insight into kind of what's happening on your ZOS queue managers. So in the 9.3 long-term support release, we actually added a new SMF statistics for queues, which provided you just initially the framework to enhance this moving forward. And so in the 9.3 LTS, you can just kind of get SMF records that just reflect the current depth of the queue over time. So that allows you to just kind of understand what's normal and see patterns in maybe how the depths of the queues are kind of like being reflected based on workload patterns. However, in the 9.3.1 release, we've added a lot more information to those SMF records that reflect all of the other attributes that you can get from running display queue status. So you can now kind of drill down in those SMF records and see more detailed information around open counts, the age of messages, how long messages have been, when messages have been put and got, and so forth. So that allows you to actually have much more information around how your queues are being utilized. And because statistics are relatively cheap to capture, it doesn't have the kind of like the cost of turning on the full accounting records that that MQ also supports. So one thing worth mentioning is that these records are generated all the time once you've turned on the capture of this information. You don't need to specifically enable queue monitoring or anything like that, because MQ was already having to take account of tracking this information anyway. So there's no need to kind of like particularly turn it on, because it's always been captured internally anyway. We're just now writing it out to SMF. So there's a lot more information that you can understand about this, and so there's an article there in our documentation which allows you to kind of read more about it. I mentioned about streaming queues earlier. So in the 9.3 long-term support release, streaming queues were supported on ZOS, but only for private queues that were local to an individual queue manager. In the 9.3.1 CD release, we've now opened that up so that you can now also use streaming queues with shared queues in a queue sharing group. So you can either have a shared queue stream copies of its messages to another queue, and you can also have a messages be streamed to a shared queue. So either the source or the target of that streaming operation can be a shared queue. We've also been continuing to focus on our MQ console, which is a web UI. So we've had the MQ Explorer, which is an Eclipse UI for many years now, but in the last few years, we've been developing and enhancing a web UI, which provides obviously a much easier way of connecting in and viewing data without needing to install an Eclipse installation on your individual machine and so forth. So we've been focusing on adding support for different things into this console over time. And in 9.3.1, we've been focusing on allowing you to connect up and see what connections are being used for, and then kind of drill down to see what's actually happening with those connections. So This is all under a broader observability theme. So, so you can look at your channels, you can then easily see what those channels are, what queues those channels are using, whether they're sending or receiving messages, and so forth. If you're sending to queue managers, which queue managers they're connected to. All the information is something that you've been able to self-determine from kind of like doing MQSC commands and things like that, but it's providing it in a much more kind of user-friendly UI environment to allow you to kind of like easily see what's happening in your environment. So, so again, this is something that's a theme that we're likely to continue to enhance. And the beauty of the console is that you can connect to both local and remote queue managers, so you can deploy the latest version of the console and still connect to other queue managers, irrespective of what version of MQ that they're running. One of the other things I wanted to just mention before we kind of open up for other questions is that kind of one of the other related products that we have in the IBM integration portfolio is IBM Integration Bus. So there's IIB 10 is the latest version that has been available until recently, and which was then kind of like moved forward to be kind of the later versions of the capabilities that this offering provided were running in something called App Connect Enterprise that was designed for different environments. With IIB 10, we've now released a revision of that called 10.1, which actually enhances and provides continued support for this offering on the ZOS platform out through until 2030. So you haven't got to migrate over to the new App Connect Enterprise offering. So IIB 10.1 is available to run on ZOS only. You actually develop your kind of message flows and so forth on Windows and Linux. And IBM has done this to ensure that you can continue to run IIB on the ZOS platform in the way that you're used to. You can continue to kind of exploit needs such as running message flows that need RS coordination, and you then don't need to kind of like change over and move how you're running your brokers to use App Connect Enterprise inside your container extensions framework. You continue to run IIB as you've been used to. At the same time, we've updated various dependencies and provided support for some additional nodes in workflows to operate with data sets and so forth. So not something that's particularly core to obviously to MQ, but it's a related offering that we know many customers use together. So just wanted to mention that as an additional extra thing on the end of this session. So if you are using IBM Integration Bus and you want to understand more, then you can go and look at the documentation, or you can reach out to us and we can get you the information that you need. Okay, so I got a few minutes obviously left for the session, but those are most of the content that I wanted to cover, but I also wanted to make sure we had some time left for questions as well. So so there.
Jimmy,
yeah,
yeah, Praveen, it was follow up from about native HA, I think.
Yeah,
and the question was about if the containers on ZOS ZXC is usable.
So what containers on ZOS is native HA usable? So if I'll quickly go back to where the native HA slides were. Obviously, way to go back. So at the moment, native HA is available for containers running in OpenShift as part of Cloud Pak for integration. So it's not something that's available to run on ZOS in ZCX, or it's not something that you can use outside of container environments in other platforms as well. Now, it is something that we have been asked about, and so we are looking to see whether that's something that we can grow the environments where native HA is available. But at the moment, it's only available for running in OpenShift as part of Cloud Pak for integration.
Brilliant. So just to mention, you are now able to unmute yourself if you have any questions that you want to ask directly without putting it in the chat.
Yeah, hi Jamie, it's Richard here. quick question about the streaming queues. So I noticed right at the beginning you were saying about there were, where you had your grid and it said streaming queues, it said ZOS. I just want to check, is streaming queues also available on the distributed queue managers as well or not?
Yes. So streaming queues is available on all the platforms. Yeah, so you can use it on all the wherever your queue managers are running. It's not a unique ZOS thing. The ZOS specific comments I wanted to mention was just around the fact that in the 9.3 long-term support release, you can only use streaming queues on ZOS with private queues. If you want to use them with shared queues, then you have to upgrade to the 9.3.1 continuous delivery release that came out at the end of last year.
Okay, and there's a follow-up question. So with the stream queues, we were shown an example yesterday where basically it was a local queue, messages were put on there and sort of copied onto this stream queue and off to Kafka and vice versa. Can you also use stream queues with queue remotes, for instance? So I'm thinking of an example. Let's say you're sending out to a third party and you want to capture a copy of that message before it goes out. Can that be done or not?
Yeah, so you definitely you can obviously stream to remote queues. At which point essentially what's happening is that the messages are being streamed to the transmission queue and then they're going to be sent off to the remote queue manager after that. But yeah, so you can definitely do that. And if I look at the example of where you might use it to have a form of disaster recovery, that's essentially what you're doing. You're defining it to a remote queue, and that remote queue is then hosted on another queue manager in another region, so that you've got a form of doing that. Now, again, obviously there's other ways of achieving disaster recovery support and ensuring your data is replicated, but that illustrates that you can use remote queues as well. There are some restrictions on what you can and can't do. So you can't change streaming queues. So you can't have a message put to a stream to a queue and have that queue stream to another queue and so forth. We don't allow you to do that. But you can obviously take the duplicate messaging and then farm it out in other ways yourself. But yes, you can definitely use remote queues.
Okay, so yes, so remote queues, alias queues, and all that sort of stuff. Anything can sort of point to a stream queue. Then is what you're saying. The other question as well: is there a performance hit if you're doing something like that, or is it negligible?
So essentially, you are obviously having a copy of the message. So there's obviously two puts being happening for each message that you've got, but it's all being done internally and optimized for the queue manager, so that it's not like a huge overhead for doing this. It's but there is obviously a cost of having additional data that's being written. One thing I didn't mention before about streaming queues is that you can actually have two qualities of service associated with this. So you can actually have it that you absolutely must have the message duplicated, and you want the original put to fail if you can't duplicate it to the streaming queue. But also you might just want to have the messages duplicated on a best effort basis, whereby if the message can be put to the original queue, you want that to happen and the application to carry on. And even if it can't duplicate it, but you want to duplicate it if you can. And so you can configure both of those options based on how critical you need the duplicates to be created for you.
Okay, thank you.
Okay. Questions in the chat, yeah.
Yeah, so what's the difference between a normal legacy cluster versus a uniform cluster? So, okay, so if we look, if I scroll through again and get to uniform cluster slides. So, so a uniform cluster is essentially a MQ cluster, but with whereby rather than having different queue managers in the cluster expose different queues and perform different roles for applications, you're actually having them all support the same set of applications, so that an application can connect to literally any of the queue managers in the cluster and perform work that it needs to. So they've all got the same queues, they're all supporting the same applications. Internally, it's still an MQ cluster, but because we now know that that's the pattern that you want to run with, we can then exploit that and actually then start to be more intelligent around how we support the applications. So when you have defined that you're running as a uniform cluster, the queue managers will start sharing with each other the applications that are connected to them. And then we will then redirect applications to reconnect so that they've got an even distribution across the queue managers in the cluster. If you're just running as a normal cluster and you haven't told us that you want to run this pattern, then we won't try and rebalance applications because we don't know which queue managers in the cluster those applications should connect to, because each queue managers might be performing different roles and it might not be appropriate for an application to connect to a certain subset of that cluster. Hopefully that answers your question. They're similar. It's just that there's some additional intelligence that we can do when we know you're running in this pattern, and therefore that's what we're just calling a uniform cluster. So if you say it's a uniform one, then we start doing some additional things that we don't do if you don't.
Yeah, thanks. I was just wondering, like, why can't it is available in GOS and why it is only distributed? So I just want to get some understanding, like what's stopping them to get into GOS with the same concept.
Okay, yeah. So obviously on so we've obviously added uniform clusters on the distributed platforms, particularly around these kind of like dynamic scaling environments, such as if you're running in cloud and so forth. On the ZOS platform, we've had queue sharing groups for a long time, and when you use other capabilities of the platform, such as Sysplex distributor to kind of workload balance applications across the queue managers and so forth, then you get a lot of the same qualities by using a queue sharing group anyway. So there's maybe not quite such a need for the uniform cluster capability there. The one thing that the queue sharing groups don't give you that uniform clusters do is the targeted rebalancing of applications from one queue manager to another. But if you're because of the way queue sharing groups generally work and how particularly if you're using shared queues, then actually sometimes it doesn't matter particularly which queue manager the application is connected to, because they can still get access to all of the same messages. Whereas with a uniform cluster on distributed platforms, because each queue manager's got its own private queues, you definitely need to make sure that all your applications are spread across all of the queue managers. So you haven't got a queue manager there that's not got any applications connected to it, where its messages will just sit there and not be processed. So that's really why we had to add the application rebalancing logic on the distributed platforms, but we maybe don't have quite such a need with shared queues on ZOS.
Yeah, thanks.
Yeah.
And there was one more, Jamie, from Lewis about MQ Client running on Windows 32-bit apps can still connect to ZOS 9.3, right?
Yes, we haven't removed any 32-bit client support. I mentioned that we've deprecated 32-bit support, so that just to say that in the future we might find we haven't really got any option but to drop that because of the different features that are exposed by the platforms. It's just a trend that we're starting to see where particularly 32-bit support isn't necessarily always available by default. You have to kind of opt in to have those kind of libraries installed in the environments. And because of all the different environments that MQ wants to support, there's various dependencies there. And so we might find that over time, we can't continue to provide the full range of 32-bit support that we've had. But at the moment, everything is still there. So you can still use your 32-bit applications in the way you have done previously. So hopefully I've answered that question too.
Yeah, brilliant. Well, we on the dot actually. So if you want to go to your last slide so people can see your email, and if any more questions, maybe they could email you.
Yep. Okay. Yep. So my email address is there. Yeah. Obviously, if you've got any questions, by all means, reach out. Okay. And yeah. And obviously, yeah, please provide session feedback as always. It's always appreciated by both us and GSE. So so yeah, the link's there on screen, and I hope you enjoy the rest of the event. Thank
you very much, Jamie. This was great. Thank you very much, everyone, for joining, and have a good rest of the day then. Thank you. Cheers all. Bye.